plan here.
Okay.
The satellite radar surface shows some observation of the country operator. But they're also here, I think.
Good afternoon. We're going to get started with Weather Watch today. First, just starting with a visible satellite image from this morning. This loop runs up until about 5 minutes ago. It starts 6 hours, so is that correct, Pete?
Yes, this is the last 61-minute mesoscale visible images over Wisconsin.
So here we're over Wisconsin. And one of the things that I found interesting about this is just this wave structure you can see. Where are we?
That's it, okay.
We're just to the southwest
This
of this.
is Wisconsin, Lake Michigan is over here, Illinois, Chicago is about there.
It's really high resolution. Green Bay, Milwaukee, Chicago. So right here, this is more just a descriptor, but you can see this very sort of interesting wave structure in the clouds. I mean, these are, I'm estimating the wavelength, but really short scale short wavelength waves that are in the lower clouds. So you can see here, these are much higher clouds. We'll look at an IR image, maybe we have an same time period. We do contrast for that. So I'd argue those are low clouds here and a band of higher clouds just to the south.
This is a 2-kilometer resolution infrared.
Right, and so these pictures are showing radiation being upwelled from the tops of clouds or from the Earth's surface. In this case, most of this is from the tops of clouds. These color regions right here indicate colder cloud tops. So, and it's suggestive of a higher elevation in the atmosphere. And these warmer colors or grayer colors there are much lower clouds. So these are the high clouds just off to our south east this morning. And these were responsible for some of the showers that we saw. We'll take a look at that, what some of the mechanisms that might have helped generate those showers earlier this morning. You can step back and look at the goes east, please. So we're focusing over the western Atlantic and over North America. And we'll look at a visible first. It's a colorized visible, really nice set of images that Pete's put together for us. What we can see out in the Atlantic is Tropical Storm Leslie. It's top sustained winds of about 50 or 55 miles per hour. And that's been around for quite a while. We've had about almost 40 advisories that have been given on this particular weather system. And it's just gradually forecasted to slowly drift northward over time and eventually east-southeastward. So it'll be around probably this time next week. We may still be talking about it.
No, I want to mention is Leslie is a subtropical low, isn't it?
It's, I think, officially, we'll go to the NHC page.
I'm not sure it came from an easterly wave.
It was a high latitude storm. It was subtropical one time, tropical. Now it's
Well, that's what I
classified
mean.
as
It's subtropical in its origins.
Right.
Yeah.
It occurred right after after Florence, and it may have been indirectly tied into some of the.
I was just noticing in class, if you look at the tropical analysis, or maybe you're going to get there, but there's a succession of easterly waves now along the ITCZ.
Right. I haven't looked carefully at that, but we will talk about just very briefly this disturbance that's down here. You can put the cursor down here.
If you
This
have
is-
it, Craig, we can bring it up too.
Yeah.
If it's accessible, we can pull it up.
Right. There's a nice broad scale gyre over the southern parts of southwestern Caribbean. And in there's small scale circulations that have been emerging from the convection that's been down there. But this has been a persistent feature in the for the last couple of days just in the Western Caribbean. And it's expected now to perhaps develop into a tropical cyclone. A 60% chance of that over the next 5 days as it moves to the northwest. We can check to see if there are any other waves out there, but there's nothing that the Hurricane Center is particularly interested in.
Look at the NHC site. They show the analysis.
Yes, if you go to analysis and forecast.
Yeah.
And tropical products, perhaps. Or tropical weather products. So maybe outlooks there. That's not helpful there. Hold on. Pete. Scroll up. There's a discussion. There's a text outlook. We don't have a graphical. We used to have a. Oh wait. No, that's the same thing.
There's just like a whole Atlantic East Pacific analysis.
Slow. If you could, just slowly go over this for a second. Tropical analysis.
Yeah. That's probably, yeah.
And we want to look at look at Hobmuller's, or we could look at. Yeah, what
I'd say just go up to the Google and look for tropical, NHC tropical analysis. Who's it just there? Is that not showing here? Maybe not. No, I haven't marked.
Go, yeah. Sorry, go back, I just saw something on tropical waves. I just saw this. Oh. We've got some time, we can get bring that up next time. So what this image is, this might be just as useful, as to check the times on them, or the dates. So this is, so going from late September through the current period to go down, just scroll down all the way to the bottom of this. What this is a series of little strips across the tropical belt in the North Atlantic and Eastern Pacific. And you can sort of track the progression of weather systems across these maps. So time runs down here. This is going from the Central Pacific or near Central Pacific all the way out to the coast of Africa. And by looking at this, you can, maybe pick a cloud cluster of interest and just trace its slow progression or even stationarity to the west. Here is a big storm that's out in the East Pacific. You can sort of see how it's emerged and slowly moved toward the east over time. If we go backwards in time, that cloud cluster that we saw that was in the southwestern Caribbean is probably traced to this blow up back on the 1st of October. So these are what are called African easterly waves or tropical waves. They're sometimes used very loosely. And they're these cloud clusters that have a slight wind signature as well as a satellite signature of maybe convection. Sometimes they're devoid of convection. You can see a slight wind signature. And they cross the Atlantic periodically, emerging off the African coast. And some of them develop, some of them don't. The difference between those that develop and those that don't is still something that's subject to debate in our field. But there's considerable interest in them because once they develop, they can possibly develop into significant tropical storms. Some of them wait until they cross over the Isthmus of Panama and get into the Eastern Pacific.
It's the main source of tropical storms during severe seasons.
Right. From late.
But this year, I don't think we had anything substantial from them. I think even Florence was a subtropical origin.
Right. I think we've had more cyclones that have developed, at least for the first half of our season. We had most of our named tropical storms were from origins of higher latitudes. It wasn't until we got into late August, early September, which is the beginning of the sort of peak period for these waves to develop, that we had a burst of them. We had to get 2 or 3 that actually came from genuine waves. The rest of them, these hybrid type storms.
I wonder to what extent that's related to the westerly phase of the QBO this year. I wonder if that's more typical of that phase, because with the westerly phase of the QBO, the African easterly or the tropical easterly jet coming off of Asia doesn't usually make it into the Atlantic like this year.
Right.
And so I think that is not bringing in proper support at high elevations, and it doesn't let the storms extend up very deep without wind shear, because if they get up too deep, there tends to be more westerly winds aloft, and that keeps them from developing. So I think I don't know. I mean, nobody, there's nothing in the literature that ever says QBO has anything to do with it, but I wonder.
Right. Well, I know Bill Gray's work, and I guess it's Pablock, I can't think of his name, his student, the project that followed him. In their forecast for a season, I think the QBO might be one of the parameters they have for the number of storms when they do a seasonal forecast. But yeah, I don't think there's been a robust study of the relationship between those, but that's something.
Well, I asked Bill Gray about that before. When he was going to put that in, we talked about it a lot. And he put it in because he said he thought he saw observationally there was a relationship. He had no idea why it was. He was asking me, well, how could this be? What is that relationship?
We maybe throw it out there for folks that are taking I-75 either this year or next year. That might be a nice project. The relationship between QBO and the number of tropical cyclone frequency, or the relationship between the phase of the QBO and pulses and activity during the particular season. Interesting picture of that. We'll come back and talk about the tropics. If we go back to this picture right here, and this may play a role in as it moves to the northwest. Again, 60% chance of it's developing as it moves across the Yucatan into the Gulf of Mexico. And in fact, the latest GFS has it developing into a tropical storm heavy hurricane, and unfortunately moving toward the Carolinas by the time we get into this time next week. So that could be another problem. This storm over here, if we go back to the NHC and click on the Eastern Pacific, if we go back to home. Remember, this disturbance here, and watch, if you click here, you might still see. So again, this broad circulation that's out over the east, in the East Pacific, far Eastern Pacific. If you could move that for a second, Pete. We have the little X here, the Caribbean, this X here. Again, there's a broader scale circulation here where some of these disturbances are.
So they're really the same disturbance on either
It
side.
could be
of this.
large, right? And
Yeah.
so sometimes you'll see, separate disturbances develop from a big cluster, but this is one that the Hurricane Center is watching. But Sergio here is one that's going to be really interesting to watch, and I want to get a different perspective of this. We're going to look at the upper troposphere, and there might be some evidence that the outflow of this tropical cyclone in the upper troposphere is characterized by anticyclonic circulation and flow. We may see some evidence of that actually spreading across the southeastern part of the United States even now. Perhaps the ridge that's been somewhat persistent over the southeastern United States, I would argue, may be the result of these periodic and very frequent Eastern Pacific tropical cyclones. This is just, that's not a complete study, it's just showing an example for today. We'll get to that in just a little bit. Let's go back to the satellite image one final time and let that loop. We can also see the low clouds that are over the central plain states slowly being scoured out as the south flow turns back to the southwest and things begin to warm up. We have these low clouds all the way back up against the Rocky Mountains yesterday, are finally kind of eroding. Okay, so we've got a cool weather period that's been from over our area all the way down into to Kansas, and we'll see also that these clouds are producing precipitation with the radar in just a moment over the northern plains, and those are actually, there's snowfall actually occurring in the Dakotas today, and there may be some in the forecast for northern Wisconsin in a couple weeks. So take a look at that. But there
Not slope in Colorado again, it looks like.
yeah, and you can see the evidence of as these clouds. Some of the white in this picture are clouds. Some of this are actually snow cover. So this the Rockies are now maybe a little bit of fresh snow cover parts of the Rocky Mountains as we do that move. Let's go to the Eastern Pacific image, please, Pete.
Visible or something else?
I'm going to start with visible. Maybe we can get rid of the first couple images in that if that's easy to do. Okay, so you can see just at the very bottom, Sergio here. Doesn't quite make it. When we look at the IR in a moment, we'll see that just to the northwest of the Hawaiian Islands is this Hurricane Malacca that's out here in the Pacific. And it's looks like it's going to be getting very strongly sheared out. We'll see that when we look at the IR. And a nice, really rather deep upper trough that's approaching the west coast. Hopefully won't produce too much precipitation in our forecast city. In fact, maybe we should go to just bring up another tab for a second and check out the latest weather challenge. See how things are looking. WX challenge. WX challenge. And this is just for fun, right? It's all fun competition. Let's look at a challenge. Let's go to results. Let's look at Wisconsin's WI. It'll pop up today, WI. Or you can scroll down. Go team, right? Let's see here. So those of you forecasting, the forecasting contest are interested in what's going on here. We're forecasting for Portland, Oregon. We're just near the end of our forecast period after 8 days. These are standings, over 1,000 people that are forecasting, and you can sort of get a sense of how our team is doing. You can also go to the team page. But that's the third guy right there. Huh, not bad. Looks about right.
Oh,
Yeah, who's the second though? That's an undergrad, right?
Yeah, that's undergrad. That's Emma Sinclair. Great. And then Andrew is not even here.
He's
somewhere
forecasting from Eastern
Africa. Western Africa is also going on. But we have, a great team here. I challenge you guys to get above consensus, but I'm pleased with how things are going. That's about right.
Which of these do you believe most?
Well, this guy right here doesn't. But actually, let's, if we go back here, I think we can actually look at our team scores. Our fingers, where do you see the team scores?
Scroll over to
Go
the
back.
other side of the screen.
And we can look at the distribution.
No.
Cumulative score. Team standing. Oh, this is only 2 weeks into the contest. So, oh gosh.
We're not doing good.
Yeah. So this is a challenge to us. Here we are, 37. That's not so good. So we have to pick up our game. But we'll, you know, over the course of the semester, we'll see ourselves climbing slowly. Okay, back to reality. Here's the latest radar loop. Again, that weather system that's producing the rain in Portland. We'll check the latest maybe at the end of Weather Watch to see. They're at about 0.03 inches, at least in the last hour. They had a trace the hour before, but maybe it was 0.01 earlier. But they're looking at about 1/4 of an inch of precipitation if nature pans out the way it's supposed to. Over us, over the Midwest, we see this area of rainfall that's heading toward the east. If you look carefully, you can see this is some convective precipitation. These are individual showers and thunderstorms that have developed, and a more stratiform type of precipitation northern edge of that. We'll look at that a little bit. Another area of looks like convective precipitation that's moving from the south, moving to the northeast into central Iowa and northern Missouri. And then this broad area of precipitation that's over the northern plains. We'll try to do some diagnostics on what that might be doing or what's the cause of it. But when we look at the surface maps in a moment, you'll notice that this is an area of light snowfall in northern North Dakota. The rest of the country is pretty quiet, with again the exception of the Pacific Northwest, where that rather deep trough is beginning to approach the coast. Okay, let's look at the surface map. Please, that should be the next. Let's see. Let's bring the surface map up here, and we'll come after this. So here in the last hour is Madison, 55/53 with a southeast wind. So we're pretty close to being saturated. Milwaukee's 57/55 from dew point with some haze in the air right there. And just broadly southeast flow here, more of a easterly or east-northeasterly flow here. So there is at the surface some modest confluence, right? And we also have a north-south temperature gradient. So there is a bit of frontogenesis that's going along through the northern, just north of us, right? So that will help to tighten the temperature gradient. And we know the result of that tightening of the temperature gradient is the creation of a thermally direct circulation, warm air rising, cold air sinking, that would help sort of reinforce that. So weak frontogenesis over us that might have been responsible for
Shift
some
on that map.
light preset.
Scroll down a little bit.
Okay. You go further to the south, into central Illinois, you're in the low 60s, southern Illinois.
Look
you're
at the
in
dew points
mid-80s.
in
And then you
Oklahoma
get-
and Texas there.
Yeah, these dew points.
And look at that region.
74, 78.
There's a slight risk out right now for going from about the Panhandle up to Kansas City,
Upper Kansas City.
Texas Panhandle to Kansas City. And in that region, you see there's a lot of very high dew points to the south. And I don't,
And there it is.
Yeah.
So,
and even just south of us, right, there's a marginal risk.
right, so marginal risk for thunderstorms, severe thunderstorms perhaps just to our south, but the bigger risk is right along the Kansas, western Oklahoma, and the Texas Panhandle. Perhaps we'll look at that a little bit. That's not something I focused on, but if you want to talk a little bit about that. But yeah, one of the points that Greg is making here is also these dew points, 78, 74, 75, these are just, this is a steamy day. This is a very uncomfortable day. The heat indexes are probably in the mid-90s, if not higher. This is just uncomfortable for people. Heat stress is an issue for people that, for elderly folks as well. So this is something that's really not a good situation. But on the other hand, people that live down in Texas are kind of used to humid, steamy types of weather.
There's about a 25-degree contrast between northern Oklahoma and northern Kansas. Up there when you get up.
Right. So here's another, and part of that's due to the clouds, right? We saw that.
Probably the dew points.
Oh, the dew points.
Look at 69 going to 45 up there in Nebraska.
Right. So temperature contrast, dew point contrast. There is baroclinicity here,
Yeah.
although the flow looks like it weakens a little bit as you go northward. into the colder air, so there might be some modest frontogenesis that would help maybe focus a little bit of lift into northern Kansas. Scroll down, please, so we can look, or scroll so we can look in the, here. So as you go into northern North Dakota, you can see the areas of light snow, 32 over 32, 34 over 32, here in the north, central part of North Dakota. So, and then even southwestern North Dakota, area of light snow, that's kind of neat, all the way up into Canada. So this is, to my eye, I don't know if it was on the last weather watch or the prior one, first time I've seen flakes in the north, in the US this season. So snow has finally arrived. If you go further to the west coast, it doesn't show up directly here, but you can see the light rain that's arrived in the Pacific Northwest with winds out of the east at this point, big easterly winds here. So pretty quiet today. So let's take a look at some of the maps. We'll start off. We'll get to this. We'll get to this in a sec. We'll go back to the upper air maps, starting at 300 millibars, please. So this is the 12Z GFS analysis. So this was at 7 a.m. this morning, and we had a small jetlet, little isotech maxima that we'll see in the forecast is forecast to propagate toward the northeast. And it's possible, although it's a little bit difficult to tell from here with this rather short stubby jet with the air accelerating into the entrance region of this jet. There may have been at low levels a small ageostrophic flow directed northward here, so perhaps some ageostrophic divergence located on the jet entrance region of this jetlet entrance region. It's a very short jet. But that's a difficult diagnosis to make just looking at this single level.
Would that be a subtropical jet?
I would guess this is a subtropical jet, and the origin of this broad anticyclone, I'm going to tie perhaps to Sergio out in the Pacific.
Yeah.
And I'll show you some
But
evidence.
you should look up at 200 millibars then if that jet.
Okay, let's take a look at 200 millibars. But again, what I'm trying to do is to motivate why we had that period of rain, that rainfall earlier this morning. It may have been near the jet entrance region. So this is an even more prominent jet entrance region that shows up here. We can go back down here, but I'm looking at just sort of how rapidly the winds increase as you go in the long flow direction. And, there's perhaps a small component. It's not evident in the winds here, obviously. It's not obvious to me by my eye. There's a strong ageostrophic circulation directed from higher heights or lower heights anywhere near these jet entrance regions. Maybe down here, but we'll look at lower levels to try to diagnose why we're seeing that sort of pulse of vertical motion that crossed our area this morning. So this isn't a great example of that, but there's certainly a jet entrance region that's just to our east, and we'll see that this is propagating eastward. Back in 452 yesterday, they were talking about the arrival of this next jet exit region approaching the west coast, and the circulation around it helping to deepen a trough just off the west coast. I think we saw evidence of that in the satellite image. Sort of a little cyclonic spin to the cloud just off the Pacific Northwest coast this morning. It's perhaps a response to high speed in the fall out over the West Pacific, Eastern Pacific. But again, bear in mind, look at this broad area of very high heights. That's been characteristic over the southeastern United States, I think most of the last few weeks. And it's also been coincident with a number of storms that have moved off of away from the Mexican coast, some of them recurving back toward the Baja Peninsula of California, back or Mexico into the southwestern United States. We're going to look at the origins of this in a moment. Next plot, let's down to 500 millibars. And the flow is one little bit of you can see some evidence of a slight short wavelength trough between crossing over the state this morning. So that's perhaps coupled with the jet stream itself, but not much curvature here, so I wouldn't get too excited about this being the source of our lift. At least it's not evident to this. And again, a very large region of high heights, strong easterly flow at 500 millibars over parts of southern Florida around this anticyclone. And there you can see Sergio shows up at this level pretty nicely with a strong cyclonic circulation, which will intensify as we go downward as it's warm core. If you want to look for regions of strong curvature, here's that nice upper trough that's approaching the west coast. And here you go from cyclonically curved to anticyclonically curved, so it's probably very likely strong divergence maxima just east of this region, which is going to help lost a significant upward motion as this begins to approach the coast. At this level, with a westerly flow, and you have the mountains along the Pacific coast here, that's also going to provide some lift for precipitation, orographic precipitation.
Yet they're only getting 0.2 of an inch of rain.
So, right, so far, but I think the mountain peak's probably going to get more. There's probably a shadowing effect. That's something we should look at. We can look at the forecast accumulated amounts
I
there.
guess the coastal ranges, they're gonna get a lot more rain.
Right.
At the rainforest, so.
Okay, let's go back. Let's go down to 850 millibars. And here's where things begin to get somewhat interesting. We saw evidence for it when we looked at the surface map, and it's even evident here now. Notice, if you look at Wisconsin this morning, really strong thermal gradient or baroclinicity that we see that's draped along across our area into the to the Dakotas. We also have, with that, we saw a leaf 500 millibar trough. You also see here there's significant curvature across this. It's almost like a warm front. And there's localized warm advection in this region. One of the diagnostics, if you look at a quasi-survey diagnostic for ascent, is localized warm advection, or plotting of the temperature advection. And that shows up really nicely over us and to the east. So this geostrophic temperature advection being really strong and warm here. You can see some evidence of diffluence as well along that frontal zone. That's going to be a region where we might expect to see upward motion this morning, and that's advancing slowly to the east. So that's perhaps one of the reasons we're seeing that. We saw some precipitation that was more convective to the south over parts of, I think it was Indiana and Ohio, and maybe argue that there's some lift there, but this is in a region that's unstable. So we can look at lifted indices. You have some lift air parcels from the surface, and the atmosphere is unstable. You might then begin to get more convective precip that would not be diagnosed directly from many of these sort of more traditional quasi-geostrophic diagnostics. Let's go down to 925. We'll just see the same thing, but we'll see the baroclinicity shifted even further, a little bit further to the south. It's a little bit more diffuse here, but really strong evidence of warm advection to the south and almost neutral temperature advection to the north. So that's going to help pack these isotherms. And that would be the focus of some assets that we left.
Is that the tropical cyclone out there?
Right here?
Yeah,
Yeah,
it
that's
seems
Seattle.
too close. Okay.
No, that's where it is. Here's Bermuda, just to the east, northeast of
Okay.
Bermuda. Again, that's been lingering for a while. It's
I wonder, that the outflow from Sergio is gonna get over that.
Yep.
Tropical cyclone.
Well, we'll see how far it gets, and we'll look at that. Actually, let's go. That's going to be our next stop. So Greg's suggesting there might be the outflow from Sergio might eventually spread over this, and that could provide an environment for this tropical cyclone to continue to intensify or to maybe re-intensify. Let's go here. This is the GFS. Let's go to 0 hour on this, please. Okay, and then scroll down just a little bit. So what is this map? This is a map of what's called the dynamical tropopause, or dynamic tropopause. In this case, it's pressure on a surface of potential vorticity that's the 2 PVU surface. So these colors here, these lower colors indicate where you have a strong upper trough. You can see that in the winds that have been interpolated onto this map. These warmer colors here are tropopause that's relatively high. We're looking at tropopause height that's almost above 100 millibars or so. So this air, Sergio is down here. You can even see some anticyclonic circulation around it. And you can see this broad plume that extends from Sergio's latitude and even east of Sergio. It's not too tough to use your imagination that this air is spread across even the southern part of our state or across the mid-Atlantic and curved back anticyclonically as this wave is broken. In fact, it's dragged in some higher potential vorticity air, a lower tropopause over the Gulf of Mexico at this point. If we go back, let's go back 24 hours and just advance with the keys. We can just click on it. We can go forward in time. You can sort of get, again, this sense, the flow out of the southwest here. And if you step forward in time, you can just watch this as it kind of breaks anticyclonically. And again, I don't think it's too tough to imagine this emerging from this latitude. I don't know if you would agree with that, Greg.
Oh, yeah, I totally agree with that. It's interesting that the Gulf is sort of very, very,
The trouble is a bit lower here.
low, yeah, which is, we were talking about a storm moving in the Gulf from the Caribbean.
Right.
It's gonna have a hard time.
It's gonna have a hard time unless it can develop its own deep convection, and we'll see in the forecast what's gonna happen with that. So let's step forward. Are we now at 0 hour?
Yep.
Let's go forward in time and just, you can step forward. This is 6, 12, 18. You can see this sort of breaking over time. Now watch down here. What's emerging? Remember that wave was down here in the south of Jamaica. Notice that the dynamic tropopause is getting a little bit higher in this region. All right, you can see an anticyclonic circulation that's getting really prominent. This is suggestive of maybe very deep convection occurring here, raising raising the roof of the tropical Caribbean here with the storm perhaps beginning to develop. And a little bit further in time, we see this anticyclonic circulation emerging just off the tip of the Yucatan Peninsula. This is a nascent tropical storm at this point, and you can see around it we have this broad area higher than the surrounding dynamic tropopause. We can keep stepping forward in time, and this actually ends up tracking to the Gulf Coast as maybe a strong tropical storm or a weak hurricane as it makes landfall in the Florida Peninsula. But again, dragging along with it, you see this strong anticyclonic recurved flow and the high dynamic tropopause, which is characteristic of an environment which a tropical cyclone might create. We're at what hour? This is 138 hours. So it's the middle of next week, Wednesday evening, Thursday, or early Thursday. This has made landfall. We'll look at the surface depiction of this in a moment. But if we go back again. Okay. The storm that Sergio is way out here in the Pacific at the beginning of this period. And over time, it's moving westward in the forecast, and eventually it begins to recur. Unfortunately, these maps that are produced here don't go far enough eastward for us to see this, or westward for us to see this. But over time, you can see, and Sergio's back at this location, you'll see it coming back into the picture. $108. There it is right there. Okay. And you can see associated with it, this plume, another surge in this plume as it begins to move. So this is probably kicked out by a very deep trough in the Pacific, helping it advance it northeastward, crosses the Baja Peninsula of Mexico and the southwestern United States with a lot of rain. And again, this is the remnants of a hurricane now moving across into Kansas and eventually closer toward us. But you can see this outflow, which is anticyclonic birds around it. This could be another producer of rain for us. And we maintain this really high, this gradient you see right here is perhaps the edge of this tropical jet over this region all the way into the Midwest. So a very high tropopause, dynamic tropopause remains down to the south. Some work that Ross Lazier did a while back looking at the outflow of these tropical anticyclones and the impact that they have on the climate. This is kind of an interesting question. What role do tropical cyclones have in the longer-term subseasonal climate, if you will, anywhere globally? Because you get this exhaust of their outflow that stays in the upper troposphere for a long period of time, and that can have an impact on local or regional climate for a season or so shorter than a season. Let's go back one more time to the beginning, to 0 hour, and focus on one last thing, and then we'll begin looking at the forecast. If you step forward, just go forward 24 hours. So you see here, flow is very strongly curved. We see a little bit of, if you will, lowered dynamical tropopause over us by tomorrow morning. There's a very strong upper trough here, not a strong upper trough, but we have a tropopause fold that's just to our northwest. If we go forward a few more time steps, it doesn't really quite make it here as this region begins to rebuild. So we're going to be on whatever environmental conditions we have right now. Looks like they're going to persist at least for the next 48 hours. Let's take a look at that. But before we get to that, we've got a wet fall. If we go to the Madison page right here, this is the precipitation.
These are updated as of today now. So he just started the new one. He said he didn't see October 1st, it's 2 inches until he realized this little green thing right there. So the first day of October, we started with 2 inches of rain.
So we're already above normal. So let's go to the one from the last we call the rain year, I guess.
Yeah, this is the snow one then too, but then last year's are still up there.
Right. So when people look at the year, what's it called, the rain year? I'm trying to think of the right.
Yeah,
the right term.
Water year.
Water year.
You mentioned it this morning. I don't remember what it said.
So this is the water year, and so it goes from October 1st to October 1st or September 31st. Water year. And so this blue line is a average over the last 30 years. These 30-year moving averages. So in a couple of years, this is going to be updated for our new climatology. And then this green is actually what's been observed. And as you can see, we've call that really wet period we had in August where we ramped up significantly. But really from late spring through now, we've been extremely wet. And we've already started the new year, this new water year, already with 2 inches above normal on the first day. So if we scroll and we look at the snowfall, that'll become relevant at some point. We obviously ended this ended in July, but we were below normal then. And we'll just see if how this year pans out. Let's scroll down a little bit more. Again, we'll be coming back to these over the course of the academic year. Looking at this, no snowfall yet, so no green showing up here just yet. And then, again, first few days of the month being plotted right here. We're already above normal. We'll see how that persists. I think we're going to see it persist. Next, what's the forecast for the weekend and coming up? So what I'm going to show you here is what's called the SREF, the Short Range Ensemble Forecast. An ensemble forecast is a collection of forecasts that are made by either using different models, different initial conditions. You know, every time you run a forecast model, the forecast model represents our state of the knowledge on how the atmosphere works, right? That's what a model is. It's a representation of that. And it allows us to project forward in time an initial state to get a forecast state. Our initial conditions are known imperfectly, so we can sort of twiddle with those a little bit within the range of uncertainty, expected uncertainty. And a representation of a model, what the physics of the atmosphere, how it works, we know pretty well, but we don't know perfectly either. So we can use different representations of that to create an ensemble forecast, initial conditions as well as different models. And so this is a collection of short-range ensemble forecasts running from 12Z on the 5th all the way out to about 0Z on the 4th, so 3.5 days or so out. Looking at the forecast, and the variable that we get plotted here is just the hourly temperature. The average of all these different forecasts is this line right here. Okay, so we can see on average, you know, the models are forecasting a big warm up by the time we get to early next week, about 75, I guess this would be on Monday. But you can see the variability in the forecast. They're kind of tightly clustered at the beginning, as you might perhaps expect. But over time, that broadens, which is a suggestion that there's greater uncertainty in what our temperature is going to be by the time we get to 18Z on the 6th, or 18Z on the 6th, which would be Sunday afternoon. I'm getting my days right now, like tomorrow afternoon. There's uncertainty for me in just what the day of the month we were. That's tomorrow afternoon. So it could be anywhere as warm as maybe 72 or as cool as 48, one of these models has. So big spread of the temperature. We'll look at the loss in a moment. And then you can see Sunday looks like it's going to be very low variability in temperature. And I can guess one of the impacts of that, or one of the things that would cause that, is if we have a lot of cloud cover, right? Or precipitation that's going to mute any of the diurnal cycle in temperature. But by the time we get to Monday, we're going to be significantly warmer. We can also click on precipitation, 3-hourly precipitation. And you can see here, like it's a relatively dry period. Overnight, we get a burst of precipitation again. Generally dry tomorrow, at least on average from all these models, clustered towards 0. And then a lot of precipitation as we get into during the day on Sunday. Possibly a lot of precipitation, up to 1 inch, but the average of these models is about 0.2 of an inch or so. But cloud cover precipitation will kind of mute your temperature on that. It's all over by the time we get to Monday.
When it says an inch, that's an inch in 3 hours?
That is an inch. That's actually 3 hourly. That's an inch in 3 hours. It's a good point. So let's look at the total QPF. Thank you for pointing that out, Greg. That's an important distinction. So here's the total accumulated precipitation for all the forecast models from 12Z today all the way through 0Z on the 9th. Okay, and we have one lonely model out here that's giving us in excess of 5 inches of rain over this period.
That'd be for the remnants of Sergio. About
That's I don't think it's far enough out at that point. On average, these models are suggesting we'll get about 2 inches of rain, which is still pretty wet, given the recent conditions that we've had. So flooding potential is certainly something we want to watch for. Again, tonight or through the night, generally dry, maybe a little bit of light precipitation. We may pick up, again, on average, these models suggesting about 1/2 inch over the period tomorrow, or between tonight and tomorrow. Not much happening, kind of slowly ramps up on average, and then another burst of precipitation when we get into Sunday. So we can get these, we go back here to scroll down a little bit. We can actually see, you can get different sites around the country for that. While we're at it, since we're talking about Portland, let's go out to Portland and click on that. And we're forecasting through 60. The temperature's okay. I think we all did poorly on the temperature, but the preset, those in the know, if we look at the total on QPF, we're going for about a quarter inch of precipitation by 6Z. And some of these models got it right, but on average, it's about 4/10 of an inch, perhaps, or maybe as much as 8/10 of an inch if things are really crazy. So I don't know. We'll see on the forecast. But that's another resource for those of you forecasting contest, looking at these. Now, a couple points I want to make about this. It's nice to throw this up here and talk about it. We can talk about, well, when they're close together, there's a lot of certainty. When there's a lot of spread, a lot of uncertainty. But that's making an assumption that each of these forecasts is in some sense equally likely. And the way that they produce these ensembles, there's still a lot of work that has to be done in refining how to construct them so that we can actually statistically make some sense of these. Because if the models are if the ensemble is poorly constructed, you can't just simply say, large spread, great uncertainty. I mean, it's okay to do it in a broad sense, but you can come up with probability distribution functions or density functions for the temperature or the precipitation amount at a given time by post-processing this output in a meaningful way. And that's something that there will be
Something
a
that's
course.
suspicious about that when I look at it, because normally you see clustering of solutions and
Right,
they're
this
like
is
all
kind of-
equally spread. How does
Right.
that happen?
So one way to sort of look at this is we can actually let's look at only the ARW models. This is the NCAR ARW model. That's the spread that you get with that. The NMB, I think, is the NOAA's model. That also has a wide spread there. This may not be the best station to look at. Maybe because of orography, and you have a whole forecast here. Let's pick a different location just to mix it up. Maybe go back closer to home. Let's go back to Wisconsin. There. Yes. Okay, and then we can just look at the difference between different models. So these are different, what are called dynamical cores. This is all from one NCAR model, the National Center for Atmospheric Research, their version of the WARC model. And then this is the NOAA's model, NCEP's model. And you can see there's a difference on average between these. And so you can begin to distinguish between different clusters of model, different assumptions made on how the atmosphere works at some level. It's manifest there, but again, there's a lot you can glean from these, and this output, some of it's available here in our department. You can actually go through and study that if you're interested in that issue. Okay, so what's causing this preset? We've gone through this. Let's go to pivotal. Briefly, this is the 0Z 925 millibar temperature. We already saw temperature analysis for peats, nice maps and super peats, but this is just in color from the GFS analysis. You can see the strong warm advection that becomes modest warm advection here. So the frontogenesis that was over us this morning that perhaps was in some part responsible for some of that preset. Let's go to scroll down to the surface pressure.
When you say the frontal genesis was
Right.
responsible for preset.
Okay, yeah, so let me link.
Isn't
the links
that
together.
the same? Like I think of it as when the winds are moving up the ramp with the front. The winds are coming from the south and then riding up the front.
Right.
You're calling that frontal genesis.
Well, it's frontogenesis, but there's another aspect. If you have an isentropic surface, right, it has a slope
Right.
to it. And so this is why we need a board here. It'd be nice to write on this. But if you can imagine, this is northward, everyone that's out here, this is northward, right? So this is a cross section. The air is ascending along a surface that's sloped.
Right.
But if the air is ascending on that surface and the surface is moving at the same speed that the air is moving northward, the parcel of air is not going to be able to ascend. So it has to move relative to that isentropic
Right.
surface, which would be, I think part of that's going to be a frontogenetical effect because that helps to
It's
bring it.
moving up the ramp and the ramp is moving. But I mean,
You have to move at the same speed.
I mean, the idea of it's like you developing the front from scratch, but you're not.
No, the varicosity already exists.
Bare
you're
Clinton,
getting
the front
stronger.
is there and the air is approaching it and riding
Right.
up it like it's going up a mountain.
But it has to be moving slow relative to that mountain.
Yeah, so the mountain's moving, it's moving, and as long as it's approaching the mountain, it's going up. What's so genesis about that?
That's going to cause a collapse of the isotopes. Let's bring the isotopes a little bit closer together. I hear what you're saying, but is frontogenesis the same thing as isentropic upwelling?
Yeah.
And I know Greg Costello would have a different answer than I'm offering you right now.
I think it's isentropic upglide, period. I mean, I don't think you have to call it genesis. No, it's genesis and Lagrangian, so if you're
Right.
following the particle,
Frontal
then
and
it's
parcel.
moving into a frontal
Right.
zone, but that's not really what, I mean, that's not fair. I mean, I think it's moving up, it's frontal upglide.
Right, but the air parcels here that are ascending, right, they're
Right.
ascending. Here, there is no warm advection here, so there's
Right,
gonna be a
because
bunch.
it's three-dimensional, those are a different elevation, isentropic.
Right,
So that's, yeah, and isentropically, it's just riding up
so we should,
the
all right,
isentropic
okay.
surface, period.
So we can actually produce, and we'll do this, maybe we'll have it next week, certainly later on this month, we can produce those isentropic analyses and look at that. This,
It's what it's doing. It's
It's what
just,
it's
it's
doing,
a
but we can-
front. That's the whole conceptual version,
over
or
front, right,
Bjerknay's concept of a front. The air is riding up the front. That's all it is. Frontal genesis nonsense. It's going up the front. The front's there.
the front is there, there's no question about that.
Yeah.
But is the front, in a Lagrangian sense, is that front intensified?
Oh, and I like Lagrangian sense, for crying out loud. We just have hurricanes developing because I run into it from somewhere else.
That's a different, whole different.
No, it's
story.
not a whole different thing.
Oh,
It's
it
that
is.
same idea. It doesn't work.
But it is veterinarian approved.
Very true. I don't get that.
It's written there, it must be true.
Oh. Okay. Let's go to 6 hours. And let's look at the precipitation. So we're gonna go surface precipitation. And so we saw this on the radar. This is accumulated precipitation ending at 18Z. So this is some of the rainfall that we had earlier today. We saw there's the snowfall that we had seen in the actual surface observations. And we can go ahead, we'll jump ahead to 24 hours tomorrow morning. So we're expecting another period of precipitation over us. And we can diagnose it through a number of different, another set of different diagnostics. I'm going to look at 850 millibars on this and temperature. We can see how the air is moving relative to that front. One picture, one interpretation of this, a diagnostic that at least gives you some sense of what you would anticipate the air to do, would be frontogenesis, Greg. And we have this difluent flow here. So we have cold advection here on the leading edge of this. Here's our region of strong temperature contrast. Here, the flow is almost parallel to these isotherms, so there's no temperature advection here. There's weak cold advection here. This difluent pattern is going to help.
So if
Produce.
the isentropic, if the gradients, if the temperature gradients are increasing,
Mhm.
that's frontal genesis.
That would be, that's all it is. That's just that.
That is frontal genesis. If the temperature gradients are the same, but the air is going up isentropically, I don't call that frontal genesis. That's
Okay.
just upglide.
It's right, the temperature, but you
Yeah.
still have to have the air parcel moving relative to those isotropies.
Yeah, whatever. But I mean,
Well, that's
no,
important. You
yeah,
can't
it
say
is.
whatever.
No, it's,
If it's like if I hold this stick here and I have the air riding up along the stick, well, I'm holding the stick stationary, yeah, it's going to flow.
so, so an outflow comes out of a tropical cyclone. Is that cyclosis?
No, but I think.
Well, then that's, you're telling me because a parcel approaches the front, that's frontal genesis. That's ridiculous.
But I'm not saying that.
But it's veterinarian approved.
Not anymore. This is what,
Oh, I see.
a different thing, life insurance or something, or Girl Scouts, sorry. So, anyway, that's a suggestion here. This is frontogenesis here, and we have precipitation occurring here. These are consistent, and we can diagnose that by looking at, like John's page, we can look at, from the quasi-isotropic diagnostic, that's gonna be upper Bossier. Frontogenesis is different than isentropic upglide. I'll agree with that.
Okay.
But I don't think what we had this morning was just a purely isentropic upglide.
It's never pure, but when you
don't think it's predominant.
when you label it as one thing, that means it's highly dominated by that. And it
Right.
wasn't dominated by frontogenesis. It was
Right.
dominated by upglide.
Okay, well, that's something we'd have, I want to.
I don't think we even have to discuss it. It's just,
Okay, so let's go back to precepts, and we'll just step forward. It's good to have these discussions, because, again, it's too easy to just throw a label on something we see. We were talking about this in 452 yesterday, maybe I got a little bit guilty of just making that statement without actually going through each of the steps. So we'll go ahead, 48 hours. Okay, and this is gonna be Sunday morning, and we'll go ahead just 12 hours into this, just to see the arrival of the next, so we have a little bit of precip, but it's still gonna be a wet, cloudy day for us on Sunday. Let's go to 96 hours. Okay, scroll down just a little bit, we haven't followed this carefully, but that disturbance has now emerged out of the tropics, is now in the southern Gulf of Mexico. We go ahead and do 120 hours just to follow its development, moving toward the northern Gulf Coast. There's rainfall ahead of this next weather system over us, but let's just track this into 144 hours, another 24 hours, made landfall, it's now over Georgia, and another 24 hours, and there's Sergio at this point.
You know, I was wondering, and I was talking about this in class earlier, how unusual is it to have so many tropical cyclones hitting Baja, coming, recurving back like that? Is that really typical?
We might get one every few years or so.
Yeah.
And this, in a single year, seeing two or perhaps even more, that's unusual, I think. I think the frequency has been higher than that. This is already, next week, we'll see if this actually verifies, but a pretty intense cyclone located over New Mexico at this point. You get a lot of rain all over ports of eastern and central North Carolina where we need it. It's actually Sergio, the remnants of Sergio moving into northern Missouri by next weekend. If you could just, I'm going to show you some difference. We talk about differences in initial conditions, differences in model forecasts. You can also create ensembles by looking at forecasts that were initialized at different times. You go to the zero-Z analysis.
I want to point one thing out
Yeah.
before we move on. You just said that was the remnants of Sergio, which I agree. But would you say that moisture that's falling there is coming from Sergio?
Probably not.
That's
believe so.
right. When you think of the remnants of Sergio, it's really just,
dynamical
it's
circulation.
really what you see at 200 millibars.
Mhm.
But what you see at the surface is being drawn from the Gulf because of the 200 millibar circulation.
Right, or just the circulation that didn't get disrupted by crossing
Right.
the mountains.
But I mean, the thing to point out that I think even television forecasters screw up
Mhm.
is moisture does not make it across the Rockies.
Right.
I mean, you can't get any substantial moisture to cross the Rockies. You can get a little bit up high, but it's like a very small amount of precipitable water. The precipitable water that appears on the eastern side is drawn up by the circulation that crosses up high.
Right, so this has moved over, east of the Rockies, clearly, you have the Gulf of Mexico is coming wide open. And the air, it's relatively dry, it takes a long time to get lifted,
Mhm.
isotropically,
Yeah.
before it's gonna cool and condense and form this precipitation.
So the dynamics that are driving that are from Sergio.
Right.
It's not actually Sergio's moisture.
That's right, I agree 100% with that. But if we look at a forecast that was initialized just 12 hours ago, last night, look at this. This is also the remnants
Oh
of
my
Sergio.
gosh.
This is an all-out blizzard in parts of the Iowa and central and northern Minnesota. This is serious business if it were to.
What are we looking, at?
This is the forecast for
Is that
a
snow?
little over a week. That's snow. This is snow. There's wind. We can look at the accumulation.
This is for when?
This would be early,
From a different
Week and a half.
forecast, but
about a week and a half from now. From the GFS forecast, valid, we can scroll back to the top of this, Saturday, 12Z, 2 Saturdays from now. Again, I'm just showing you the differences in what happens to, how the forecast has actually changed. So if you look at the accumulated precipitation, we'll just do a standard total snow. And we can go over that. Look at 1.5 of snow in that strike just north of
19
the
inches.
cities.
But it stays all over the state.
Right, not in our, not in our city. If you go, again, look at the 60, so forecast initialized 6 hours later, gone. And we go to the one from 12Z, morning, that's gone. So this event it's evolving in a totally different manner. Maybe it's a little bit slower if we go ahead to 216 hours. Yeah, we're not getting much from that. Well, that's kind of interesting. If you go back to the more robust storm there and then go to the ECWF, I'll leave it at that. See, that's sometimes a very reliable model. We can't see the snowfall there, but we can actually see a pretty decent storm. That's actually what they developed. I think that's the same storm that we saw in Carolina. It's a little bit slower. Go to 10 days out. Maybe sort of go together. So that's actually Sergio and Gulf of Mexico moving in, but that's really getting cooler for us in the forecast. So the short outlook is this weekend looks like cloudy with periods of rain. Tomorrow might be drier than Sunday, and warming up by the time we get to early next week. And it'll be interesting to watch how Sergio crosses over the mountains of Mexico and the Southern Rockies, because that could be a big weather player for us.
For tomorrow and Sunday, what is your expectation for Dane County?
What, you mean in terms of temperature or rainfall?
Rain,
I don't have the number at the top of my head. If you could bring up the, moss generally does pretty well. I was gonna forecast on a roll, gathers no moss, but I'm gonna violate that, just, I'm not really rolling forecast. That window over there, I think, is what you want. And / new ABN. And then, as I said last, so these are the model output statistics, sort of takes the output from the forecast model, statistically close processes it to look at, to correct it based on model biases and things of that sort. And so it's looking at 59 and near 60 for the high tomorrow, 50 for the low. And actually, the probability of precipitation a bit, it's highest in the morning tomorrow, then it decreases during the day. And then tomorrow afternoon, it comes up a little, or Sunday afternoon, it gets back up into 75% or so. It's wet, but overcast for the entire weekend, and winds generally out of the north and northeast for most of it. In terms of how much precip, we go /EXT ABN. These are interpolated model data values right to the location. And those of you that are making forecasting in the forecasting contest, hopefully you're using some of this data. It's generally pretty good to use. Why is it so slow? Someone copying in file?
I don't know.
Okay. Here we go. If you make the window just a little bit larger. Okay. Here's the temperatures, and here's the precip about to come up. And we also have the Shref that we can look at as well. But 0.08 through noon today, and then overnight tonight, 0.07, 0.25 ending tomorrow morning, and dry most of the day tomorrow, and then another during tomorrow, Sunday afternoon, another probably 0.2 of an inch or so, or just under 0.2, almost 2.5 tenths. 0.25 inches liquid precip during the day on Sunday. So, rainier than day tomorrow is going to be drier than it is going to be on Sunday.
Tomorrow night for the game looks okay.
Right, the game,
6:30.
yeah, it looks like it should be generally dry.
One of our online viewers mentioned, was wondering if any of us remembered in 2007, the same weekend, we had record highs in the mid to high 80s. Don't recall. I'm not a weather, well, I guess I'm a weather geek, but I don't remember that specifically.
Yeah. Anyway, thanks for your attention. Thanks for the great discussion and questioning. That's always good to have at Weather Watch, and hope you guys have a wonderful week, and see you next week.
2 weeks from today, the Alumni Engagement Board is hosting an alumni open house in our department. So we'll have a bunch of former students wandering the halls and coming to Weather Watch. And so
that's on
there'll be
Thursday.
pizza that day too. What?
That's on Thursday, right?
It's on Friday, October 19th, I believe. So,
The open house.
yes.
And I would think for that thing, we're gonna have something after the weather watch for that,
Something after the Weather Watch.
with the alumni engagement board.
I've got a schedule that they just finalized today. It'll be posted in the halls. I think 10 o'clock, there's a meeting with the chair if you're available, or other faculty I know you teach. There's a couple of classes that they're opening up that they can go and sit in on. Weather Watch.
Well, I'd like them to talk to the,
There's a time
class.
there's a time scheduled with students between like 1:30 and 3, I think.
yeah,
And in terms of talking to the natural hazards class, I think that's one of the classes listed on there as being available to
Okay.
visit.
so we'll plan to work with them in the natural hazard.
Yeah, I think they have coffee time from like 9 until 10 or something, so we can mention just offhand that, we encourage any of them to come and talk to the class.
Okay,
All right, thanks.
Thanks.
all right, I'll be over there in a few minutes, I gotta go up and get my computer.
And it was all that we did.